Hello, everyone, and welcome to Pre-Calculus Algebra Lecture number 9. This is about circles, and here's how we define a circle. A circle of radius r and center hk is the set of all points in the xy plane that are a distance of r, the radius, from the center hk. We've drawn the graph of the circle here. And every point on the circle is the same distance from the center AK. Every point on the circle is a distance of R from HK. So let me take this point right here. The distance from this point P, and we'll call that XY, to the center HK, the distance from the point on the circle to the center is R. If I take a different point on the circle, maybe over here, and I'll call this P sub 2, X coordinate is X sub 2, the Y coordinate is Y sub 2, the distance from this point to the center of the circle is R also. If I pick any point on the circumference of the circle and go to the center, that distance is going to be R. So here we have a circle of radius R and center at the point X equal H, Y equal K. That's what a circle is. Now, could we perhaps figure out what equation in terms of X and Y can actually produce this circle? Let's analyze what we have and see if we can actually come up with an equation in two variables that gives us the graph of this circle, or gives us this circle as a graph. Okay, here's our circle of radius R and center K. And I'm going to pick at random some point on the circumference of the circle. I'm going to call it XY. And this point is going to be representative of any point on the circumference of the circle. My circle has a radius of R, so that means that the distance from the center to this point on the circumference is R units. So let me draw the radius. The distance from the center to the circumference of the circle is R units. Now, let me also draw this point right here And I'll make that a black point. And I'm going to form a right triangle. And I think maybe I'll use black pen to do this. Very good. What are the coordinates of this point? Every point on a horizontal line has the same y coordinate. So the y coordinate here is k. Every point on a vertical line has the same x coordinate. So the x coordinate is x. And what is, this is a right triangle. And the length of this side, let's see, we go from h to x. So the length of this side is x minus h. And this side, let's see, we go from y equal k to y equal y. The difference is y minus k. And again, let me just go over how I did this. The length of this side is the distance between this point and this point. It's a horizontal distance, so it's just the difference of the x coordinates, x minus h. The length of this side is a vertical distance from this point to this point. So the length of this side, being a vertical distance, is the difference of the y coordinates, y minus k. So we have a right triangle, and we have the length of each side, and we have the length of the hypotenuse. The hypotenuse is r. Pythagorean's theorem tells us that if we square each side, or square the length of each side, and add them together, we get the square of the hypotenuse. So we take the square of this side, and the square of this side, and that's going to equal the square of the hypotenuse, r. We just came up with this equation. We take the length of one side and square it. We take the length of the other side and square it, add them together, and we get the length of the hypotenuse squared. And what this equation is the standard form of the equation of a circle of radius r and center hk. Now, let's do a couple of examples just to put to use what we've just developed. Let's see if we can do this one. Describe the graph of the equation x minus 3 squared plus y minus 2 squared equals 9. Let's see, does this remind us of something? I don't know about you, but this reminds me of the standard form of the equation of a circle with radius r and center hk. And I'm going to write that right over here. X minus h squared, y minus k squared equals r squared. And we'll just match up every piece of our equation with the standard equation of a circle of center hk and radius r. So it looks like r squared is 9, and that means that r equals 3. By the way, r can't be negative since r is a distance. So when we compute the square root of both sides, we don't get plus or minus 3 because we can't get a circle with a radius of negative 3. The radius is the distance from the center to the circumference of the circle. A distance can't be negative. So r is always going to be positive. R is 3. H is 3. K is 2. This, and when I say this, I'm talking about the equation that we're given in the exercise, is the equation of a circle. Radius 3. And center HK equal 3, 2. And although they didn't tell us to graph this equation, maybe we should. Okay, I think I graphed the son of a gun. Equation of a circle of radius 3 and center 3, 2. So here's somewhere around there. Here's the point 3, 2, that's our center. And every point on the circumference of the circle is a distance of 3 from the center. For example, if I draw a radius from the center to this point on the circle, let's see. X is still going to be 3, but we're going up 3 units, so this is going to be y equal 5. Yeah, that looks about right. X equal 3, y equal 5. And if I go 3 units in this direction, let's see, 3 units in this direction to the left. The y-coordinate is going to stay the same at 2, but we're going to start at x equal 3 and go 3 units to the left, so we're at the point 2, 0. Yep, that looks good. This is our circle of radius 3, centered at the origin 3, 2. Let's do another one of these. Describe the graph of the equation x plus 4 quantity squared plus y minus 1 quantity squared equals 16. Again, this reminds me of the standard form of the equation of a circle. The standard form of the equation of a circle with radius r and center hk. But there is something bothering me here. I have a negative sign here and a negative sign here, but up here I have a positive sign. So the equation that I have up here is not exactly in the form of the standard form of an equation of a circle with radius r and the center hk. Can I perhaps rewrite this so that it does fit the form, the standard form of the equation of a circle of radius r and center hk? I think I can. Somehow, I have to change that sign to a minus sign. So maybe this will work. There. I have x minus something here. X minus what is the same as x plus 4? If you're thinking minus 4, you're right. This is exactly the same as that, but now this thing fits the form that we have in the standard form of the equation of a circle. And maybe to make this fit even better, instead of writing 16, maybe I should write 4 squared. How about that? And let's see how this matches up with the standard form of the equation of a circle. I think everything matches up. H equals -4, K equals 1, r equals 4. This, and when I say this, I mean our equation it's a circle of radius r equal 4 and center HK equals -4 and 1. So the radius of our circle is 4. The center of our circle is the point -4, 1. Let's look at some special cases that we'll see often enough that they merit special attention. This is definitely the case if we're going to be taking trigonometry. We have the center of the circle being the origin. So let's see, that means that the center HK is equal to 0, 0. So let's look at the standard form of the equation of a circle with center HK and radius r, and see what happens if the center HK is the origin. Well, let's see. We have x minus h squared, y minus k squared equals r squared. X minus 0, that's just x. Y minus 0, that's just y. So we get x squared plus y squared equals r squared. And what is this? It's a circle whose center is the origin. This we should know. And we should also know the standard form of a circle of radius r with center HK. I want to put this someplace where it won't clutter everything. by telling you that you should know this equation, the equation of a circle of radius r centered at the origin. And let me insert something there. Circle of radius r centered at the origin. We should know that. But when I say we should know this, I'm not implying that we don't need to know this. So let me say that we have to know that as well. And let me do one more example before I tell you another form that we need to know. Describe the graph of this equation, x squared plus y squared equals 25. Well, it fits a form that we know, doesn't it? The equation that we're given fits this form, which is the equation of a circle of radius r centered at the origin. So r squared must be 25, which means r has to be 5. So this is circle of radius 5 centered at the origin. And here's the graph. It's got radius 5. So these are some of the key points on the circumference of the circle. If I start at the origin and go 5 units in the x direction, I get to the point 5, 0. If I start at the origin and go 5 units in the positive y direction, I get to the point 0, 5, and so forth and so on. Okay, let me show you another special form. This is another special form of an equation of a circle. Especially if we're going to take trigonometry, we're going to refer to this circle a lot. Now, what does it remind us of? It reminds us of the equation of a circle. Of radius r centered at the origin. Well, let's see, this part and this part are the same. So the center is the origin. And in this part, r squared is 1. So that tells us that r equals 1. Radius 1, centered at the origin. And sometimes we call this the unit circle. The unit circle centered at the origin because the radius is 1 unit. Given the equation of a circle, we might like to find the x-intercept and the y-intercept of a circle. Or even if we don't want to find the x-intercept and the y-intercept of a circle, we may be asked to find them in our homework, or we may be asked to find them on a test. So we're going to have to do this. Now, what is the x-intercept or an x-intercept? Isn't that where the graph of the function crosses the x-axis? And what's the identifying characteristic of the x-axis? Isn't the x-axis the set of all points where y equals 0? So to find the x-intercept, we set y to 0 and solve. Here's my equation. I'm going to set x equal to 0. Now, what is the only number that we can square or multiply by itself and get 0? Isn't the only number that we can square or multiply by itself and get 0, 0? So if I have y minus 2 squared equals 0, that tells me that y is equal to negative 2. Well, that tells me that y minus 2 is 0. You know what? I apologize. I am flying on autopilot. I really do apologize. X-intercepts set y equal to 0. Hello? That means x minus 3 squared plus set y equal to 0. So 0 minus 2 squared equals 9. And we have x minus 3 squared. And we square negative 2. And we have 9. x minus 3 quantity squared plus 4 equals 9. X minus 3 squared equals 5. Now to solve for x, I compute the square root of both sides. And I'm going to have x minus 3 equals plus or minus 5. And that means that x equals 3 minus 5. Whoops. Holy moly. I think I need to take a rest. Square root of 5. We take the square root of both sides, so plus or minus square root of 5. Those are the two solutions. These are the X-intercepts. 3 minus square root of 5. 3 plus square root of 5. Let's see if I can do better for the Y-intercepts, okay? Okay, now the Y-intercepts. To get the Y-intercepts, we set x equal to 0. And we get 0 minus 3 squared plus y minus 2 squared equals 9. We square negative 3, we get 9. And if we subtract 9 from both sides, we get y minus 2 quantity squared equals 0. The only number that we can square or multiply by itself to get 0 is 0. Another way we could do this, I guess we could do the square roots, couldn't we? And we get y minus 2 equals, and trivially, plus or minus the square root of 0, but that's just 0. So y equals 0 is our X-intercept. Just one. Hold on a second. Forgive me, I'm not sure what it was that I just erased, but I'm not sure that what I erased was what I really wanted. Let's do this again. The y-intercepts, we set x equal to 0. So x is 0. We have negative 3, we square it, that's 9. Plus y minus 2 squared is 9. And then we subtract 9 from both sides and get y minus 2 squared equals 0. I have something squared that's equal to 0. The only way that that's possible is if the thing that I'm squaring is also 0. So this means Or doing it another way, we could compute the square root of both sides. Y minus 2 is plus or minus the square root of 0, which is just 0. So y minus 2 is 0, and this says that y equals 2. So this is our y-intercept, y equal 2. Okay, so we have the x and y intercepts of our graph. So what should our graph look like? Well, I'll tell you what, if you look at our opening example, that's what our graph looks like. We actually graphed this function right at the beginning of the lecture. And so if you want, you can go back to this part in the lecture and just observe very clearly the y-intercept is 2. Oh, I don't have the x-intercepts, but oh, what the heck, I'll graph it again. Okay, here's the graph of our equation, x minus 3 squared, y minus 2 squared equals 9, or x minus 3 squared plus y minus 2 squared equals 3 squared. And notice that we have a radius of 3. Center is 3, 2. Here's the y-intercept, 2, 0. Here's one x-intercept, x equals 0 and y equals, I'm sorry. Oh, I wrote those backwards, didn't I? Son of a gun. Son of a gun. I apologize. X equals 3 minus square root of 5. And y equals 0. Hello, we're on the x-axis, so yes, y equals 0. And likewise, this is going to be x equal 3 plus square root of 5. And again, y equals 0 since we're on the x-axis. Okay, what did they say? Third time's a charm? Let's go on. Suppose that we have the equation of a circle in standard form. For example, x minus 3 squared plus y minus 2 squared equals 3 squared. And we multiply everything out. So we square this and we get x squared plus 9. And then we get the first times the second, which is negative 3x. And we double that. The first times the second doubled. So that's negative 6x. And we do the same thing here. We get the first thing squared plus the second thing squared. And we take the first times the second, negative 2y, and we double it. Minus 4y. And we square this out. And then we get everything on the left-hand side. Why would we do this? It beats the heck out of me. I know why I'm doing it. I'm doing it just to prove a point. But let's get everything on the right. And so I have x squared, I have y squared, I have minus 6x. I have minus 4y. And if I subtract 9 from both sides, these two things vanish. And I'm left with a constant of 4. I have this equation which really doesn't tell me very much other than it looks like it's a circle because I have an x squared and a y squared here. We get the general equation of the circle. This piece of junk, which tells us absolutely nothing. Can I look at this and say that the radius is such and such? No. Can I look at this and say that the center is such and such? No. I have an x squared and a y squared, so I feel kind of confident that this is a circle. But what's the center? I don't know. What's the radius? I don't know. This is what we call the general form of the circle. There. The general form of an equation of a circle. We don't like it because it doesn't tell us anything about the circle. Do we like to express a circle in this form? No, because it doesn't tell anybody else anything about the circle either. We hate this form of an equation of a circle. But for homework, we're going to be given something like this, and we're going to be asked to find the center and the radius. Oh, goody. Here's a horrible exercise that they may actually make us do. Given the equation of the circle, x squared plus y squared minus 6x minus 4y plus 4 equals 0, find the center and radius of the circle. Not fun, but it's well within our capability. Here's our game plan. We want to take this piece of junk and rewrite it in standard form. Well, how on earth are we going to do that? We can do it using a relatively new friend of ours, not an old friend, but a new friend of ours, completing the square. Yeah. I told you we would have to use this again. I said in Calculus 2, our students use it. In Calculus 3, our students use it. We're going to have to use it in pre-calculus algebra. So let's clear some space. And hold on just a minute. Here's how I'm going to do it. 1, move the constant to the other side. And then 2, group the x's together, y's together. And here's why I did this. I'm going to use completing the square on this expression and this expression. I want to turn this into a perfect square. I want to turn this into a perfect square. So what I want is I want to be able to write this as x plus some constant squared and y plus some other constant squared. That's what I want to do. So I'm grouping my x's and y's separately, and I'm going to complete this square separately and complete this square separately. How do we do that? Do we remember? I'll tell you what I remember. We take 1/2 the coefficient of x, square it, add to both sides. And we do the same thing with the coefficient of y. Take 1/2 the coefficient of y, square it, add it to both sides. The coefficient of x is -6. I'm going to take 1/2 of that, -6/2, and I'm going to square it, and I'm going to add it to both sides. (1/2) the coefficient of x, -6/2, square it, add it to both sides. And I'm going to do the same thing with y. Take 1/2 the coefficient of y, which is -4/2, square it, and add it to both sides. And each of these expressions is now a perfect square. We're going to simplify some. X minus 6x plus negative 3 quantity squared and there's a reason why I'm not simplifying this any further. Y squared minus 4y plus negative 2 squared. And over here we have negative 4 plus negative 3 squared plus negative 2 squared. Now we express as perfect squares. It's going to be x and whatever this thing is with its sign. So this negative 3 comes down here verbatim. The negative 3 and the sign in front squared. Same thing over here, y, and whatever this is, we bring down verbatim. This negative 2, we're going to bring that down along with its negative sign. Squared. And over here we have 4. Negative 2 squared is a plus 4. Those cancel out. Negative 3 squared is 9, or positive 3 squared. And the reason I'm squaring it, I want this to be r squared. And remember, r, it's a distance. It can't be negative, right? Now there, that really wasn't as bad as I made it out to be, was it? Not at all, not at all. And so we took an equation of a circle in general form, which stinks, and just in a few steps completing the square, we got it in the standard form of the equation of a circle, and we identified the center and the radius. That's our circles lecture, plus a few snafus on my part. Hope you enjoyed it.